Hey, this is Dr. Corey Glenn with Blue Sky Bio, and I'm going to make a video here showing a technique of how to make guides for zygomatic implants. Now, this is something a little new to me. I've not messed with this a whole lot, but now it seems like more and more people are placing these zygomatic implants, and so, they're a big surgery. You've got to flap them way up, and a traditional guide is not going to really work. It's going to allow you to make a good purchase point in the ridge where you need to, but the challenge becomes that you've got such a long drill that even the zero point 0.1 millimeters of wag room that you've got between that translates to huge deviations up at this apical end. And so it becomes necessary to figure out a way to have a secondary guide to further up along to keep your drill on the right axis.
So this is a case that I'm working on with Dr. Jonathan Abeneim. He's placing the zygomatics and kind of told me what he was going for, and so this is what I've come up with as far as how we can actually pull that off.
So let's go through how I did this. It's not that complicated at all. And the starting point for this or any bone supported guide, I'm doing this as a bone supported guide, is always going to be bone segmentation. Okay, so you're going to have to turn this jaw into an STL as opposed to just having, the CT. We can't make a guide on this CT. It's missing stuff. It's got holes all through it. So you've got to go through bone segmentation, and these tend to be a little bit more difficult segmentations, especially in the maxilla, because you've got these thin sinus walls. They're just more difficult. So I would suggest looking at the video that I've got on how I do bone segmentation. It mostly uses Blue Sky and a little bit of Mesh Mixer, but it's a hack I've come up with that makes it far easier to get a good segmentation. This is what that video looks like. So if you go to YouTube, you'll find bone segmentation using Blue Sky Plan. It's going to take you through the whole process. So do that, get your segmentation done, and now we're back at this case, and we've actually got an STL with good sinus walls. We've captured all the little pieces of bone in the critical areas, as you can see if you look through the axial slices and turn on the hint. As you can see here, you've got a good segmentation. And we're primarily concerned with the ridge, right up in this area, and the lateral sinus wall, and then, of course, the zygoma. You don't have to do the entire maxilla, but those are the areas that you really need to get. Secondarily, you need to place your implants. Now, I am by no means a zygomatic expert. I placed these kind of according to where the surgeon who's doing the case wanted them. And so if we look at this in the tangential view, which centers itself on that implant, here you can see that we're purchasing right through the lingual portion of the crest here. And then the implant is going just lateral to the sinus wall and then extending up into the zygomatic process. Okay, so both implants are placed according to those parameters you can see here. And so now let's make the guide. And I should also mention the implant that I'm placing. So if you want to place one of these implants, that's obviously not something we have in the library as of right now. You would go up here to add implant, and instead of select implant, which would give you all your traditional ones or all these different brands and whatnot, instead of that, choose custom implant and make it whatever length you want. In this case, I went with 40 millimeter implants and whatever diameter you want. So that's going to be dependent on the system that you're using. And I would go ahead and put on a custom abutment as well. So the custom abutment, you need to think about how much angle correction are you going to do. So if we were to put on an abutment, I usually make those 20 millimeters long. And let's suppose that we were going to use a 45-degree multi on this. So if I right-click this and say replace abutment, we can make that abutment be 45 degrees. And now take a look at it. Now the question becomes 45 degrees in what direction? So if you want to play with your timing, then you could look at this. When I hover on this implant, I'll unlock it. When we hover on this implant, you can see that we only want to go around the implant axis, okay? So you can play with the timing, but I'm not changing the implant position whatsoever, okay? If I undo that, you'll see that this is where that 45-degree abutment brings me, pretty much straight up and down with the maxilla. And same thing on this other side, a 45-degree abutment is going to make these more or less parallel. So you're thinking not only in terms of your surgical position with the implant, also your angle correction and how many degrees of angle correction you're going to use with the prosthetics. Okay, so the implants are positioned. You've got complete control as long as you're in advanced mode up here. Okay, advanced mode, if I was to look at this implant, I've got complete control over all the implant parameters, all the abutment parameters, and the guide tube parameters. Okay, so every implant, you're going to be able to have one guide tube. All right, and if I was to hide all but say one of these, so now we have just this implant, and we need to create a second tube up here. And the way that I do that is I simply duplicate this implant. So let's right click, duplicate. And now I have the second implant perfectly superimposed onto the first, exact same position. But the reason that's important is that now I can control a second guide tube. So let's go ahead and grab that guide tube, and I'm changing the offset. Okay, and I'm just sliding the offset up until I'm farther away, and I can have a secondary guide tube that's further up the length of this implant. You can also make the height of that implant guide tube be wider. Okay, so now you've got a pretty long tube. Now you can imagine if you just, again, went in through one spot, you would have tons of wag on the apical end of your drill. But if you go through this secondary tube, that's going to straighten you out and keep you dead center where you don't get off whatsoever. Okay, now for your guide hole diameter, that's purely dependent on the tubes that you're going to use. Let's suppose that we were going to do this for a 2.8 drill. The doctor I was doing this for just wanted a plastic guide. They didn't want to use metal sleeves, so I just made it 2.9. But if you're familiar with Blue Sky Plan and our guide tube selection, then you could also go to our website. And on the website, go to the area where we have guide tubes and choose all guide tubes, and we could find a guide tube that would be corresponding to that. So if I've got a 2.8 drill and I wanted to use a metal sleeve, then I need a 2.9 internal diameter. I can simply go down. We have tubes, multiple tubes, every 1/10 of a millimeter basically. So I could just go down until I find a tube like you see right here. And I'd just make myself a quick note that 2.9 inner diameter is what I'm after, but it tells me that the outer diameter of that tube is 4 millimeters. So back in the software, if I was going to insert that particular metal sleeve, then remember these guide rings right here, these, you need to think of them as plastic. This is where you're going to insert the metal guide sleeve. So what would you want the inner diameter of that plastic to be? You would want it to be 0.1 millimeters larger than the outer diameter of that metal sleeve. And in that case, this would be 4.1. I could change that. Now, again, I'm not doing that here, just letting you know if you do want to use that, that's how you would control it. So we've got another problem. If you just do a straight up standard surgical guide and you blocked out undercuts, the path of draw in Blue Sky Plan, as of right now, you can't manually define what path of insertion you want this guide to insert on. Rather, Blue Sky Plan is always going to make the path of draw for a guide either from straight above or straight below. So in the case of a maxilla, the path of draw for a guide that it fabricates is always coming down in this path, okay, like from the bottom of the toes straight up onto this maxilla. It's not going to fly for me here. I don't want that. It's going to end up with excessive undercuts, having to be blocked out, and then your guide ends up huge, difficult to seat. So how do we get around that? Pretty simple little hack you can do right here. Let's jump over to the denture module. Now, why are we going to denture module? Because there's a feature of denture module that we can exploit to generate our own path of draw. Now, in order to do that, it thinks you're making a denture. So first of all, I'm going to have to just stick a couple of teeth in. I'm going to grab this one and this one, just any two teeth in a maxilla, add selected teeth as a chain, shift, and drop this into position. Okay, I don't care if they're in position, that's completely irrelevant to what I'm doing. The only reason for doing that is that now with some teeth in here, I can tell it that I'm making a denture on this initial jaw, my segmented jaw. It's a maxilla, and when you push create denture, the very first step is that it asks you to define a path of insertion, okay? And we can tell it we don't want any undercuts, okay? We don't want to engage any undercuts. So now let's put more of a path of insertion on this like what we would ideally have. So it's going to be coming in. These are going to be two independent guides, a right and a left. So come in from this direction, and I'm going to go from the front of the mouth towards the back, hence this angle. And when we're looking at it from this side, remember, for this side, I'm only going to be coming in from one direction. So let's make it more of that. And here you can see this really blocks out a lot of the areas that would cause us problems. You've got a little bit of undercut indicated by that brown on the facial. The lingual's far more, but since this is mostly a buccal guide that just rests on the crest of the ridge, I don't care about lingual undercuts. I'll allow those. And so let's go ahead and click next. What the software is doing here is it's generating a path of draw model. Okay, and that's what we're after. Now, if I simply, this is going to be the model that I build this guide on, and I'm going to allow undercuts, because even if you allow undercuts, if it's being built on a model which has the undercuts removed, well then you're okay. So that's what we're going to do, but you're going to have to right now export this model. So let's go to File, Export Data. We're only going to do this path of draw model, okay? I don't want those teeth or anything else. So now I'm going to save that on my desktop and then pull it right back into Blue Sky Plan. So I'm calling this Patient's Left Path of Draw Model. Click OK. That is now exported, and I'm pretty much done in this. Now, if you wanted to, while you're still in this, if you wanted to go back, and this time if we wanted to make this for the patient's right side, we could do the exact same process. Go from there. If I'm looking at it from this side, from a lateral view, I want it to come from the anterior towards the posterior. And we could do the exact same thing again. Let's click no undercuts, next, and now we have another model with the path of draw for the patient's right side. Export it. Okay, so we're done in denture module. There's nothing else I need to do here. I could even delete these teeth because we weren't really making a denture. We were just trying to get those models. Again, just a quick hack to allow path of draw. So go back to advanced mode now. So we're back in the surgical case, and we need to pull in those models. I'd already done that, but let's just start from ground zero here so you can see it. I'm going to File, Import STL. I'll bring in patient's right. Okay, we've got that. We don't need to stitch this. Remember, unless you change the positioning of this model while outside of the program, then its global orientation is already set. So when it's asking you to stitch here, just push cancel. And now you'll see that this model is integrated in and it's in the right position. Let's go ahead and pull in the patient's left side as well. There we go. Don't need to stitch it, so I just cancel here. And now we have both path of draw models that we're going to build these guides on, okay? So let's start on patient's left. And I'm going to turn off all the other implants. So the one I want to keep is that one, and then this bottom one, remember that I duplicated. Turn everything else off at this point. And here's what we're going to do now. Actually, before I even make the surgical guide, these cases usually require you to make a window in the area of where this implant is going to go, because you might be passing right through this lateral wall, and if you've not made a window into the sinus, you get pushed buccal and it's going to mess up your implant position. So the first thing I'm going to do is, with no guide tubes turned on, I'm going to go to the guide panel. We're building this on the patient's left path of draw model. Lock the implants. This is an important step that kind of messed with me for a little while. Usually your automatic brush, which is the perimeter that it clears out for your handpiece to get into, we're going to take that down to 0. Just take my word for it. If you don't do that, it's going to be a really gnarly looking guide. Okay, so first things, we're going to make just a guide with no holes on it. And in this little gear, to make access easier, I'm going to go with a 2mm guide thickness. And usually remove undercuts is going to be on. We want to turn it off. Remember that by generating this path of draw model, even though the surgical guide is not going to be blocking out undercuts, there will be no undercuts because of the model that it's being built on. And now we're ready to make a guide. So draw curve and just make whatever perimeter you like on this, whatever amount of extension you want. No need to go very far on the lingual. And now edit curve, create surgical guide. Okay, and this is the guide that gets generated. If you don't like the borders of it, you've always got your cut tools that you can use. So if I was to go in here and use the cut tool, I could trim back boundaries, something like that. Okay, so you got the idea. You could fine tune this boundary to be whatever you want. Reduce the amount of extension if you want to. But what I'll do here is I'm just going to export this right now. I'm going to go up here to File, Export Data. I'm going to export the implant and the guide. That's the only thing I'm exporting right now, because right now what I'm making is the sinus guide. Okay, so let's export it. And we've got that. Now I'll show you a couple of ways that you could approach this. On your desktop, if you open this file now in Mesh Mixer, you could make the window of where the sinus needs to be opened up in Mesh Mixer. And I would do that by, first of all, separating these two files out, the implant and the guide. So here I've got the implant selected. They're saved as one STL right now. I can separate them by just clicking separate. Also need to repair it because you see those little mesh cut failures. So now this is ready. And what I want to do is subtract this abutment, or I'm sorry, this implant from the guide. Just a thing I've learned over time is that you always want to make these things solid before you try to do a Boolean subtraction with them. And, you know, it's still going to be the same quality of shape and everything, but it's going to do a subtraction much easier because the geometry is a lot less complex. So let's choose the guide first, and then Control, left click the implant, and now Boolean difference. And you see here it happens very quickly. I'll accept that, and we're going to save this as patient's left sinus guide. I'll just overwrite the one I just created. So that's step one. You've got your guide of where you need to make the window. Pretty easy to make. Let's go back now. And this time I'll hide that one. I'm going to turn the guide tubes on. So turn that tube on and that tube on. And this time we don't have to start from ground zero. We've already made one guide on this. So if I go back to this patient's left path of draw, I lock the implants. Again, make sure that you've got your thickness reduced to what you want and you're not going to remove undercuts, okay? I don't have to redraw the curve. I could hit edit curve and it's going to bring up the exact same curve that I used previously, but this time with the tubes turned on, it's going to make a guide that has both of those tubes incorporated. Let's create it. And here you have your Zygomatic guide. Okay, so both tubes are incorporated. So imagine now that you have the patients sedated and you're ready to do your surgery. So this is their maxilla. So you put in your first guide, which looks something like this. And if the implant were hidden, you can see that it tells you exactly where you need to make that window. And you could go ahead and make the window with whatever means you want. Get that membrane pushed back so that your drills in the subsequent guide are not going to tear up the membrane. Put some bone graft in if you want to, but this is going to keep you from tearing the membrane. And then once you've used that guide, now your surgical guide will seat. And frankly, this would seat anyway. You know, it removes the impingements. So if you were to look at this, you see here how this guide would seat even if you didn't use that first guide. But it's recommended that you do that first and open up that sinus and get that membrane out of the way. And then, even though this one would have sat, you can now put this in and not worry about the drill here where it would have perforated through the sinus wall. You don't have to worry about that tearing up your membrane. So that is basically it. Not a very complex workflow. It's pretty simple, to be quite honest. And we could print this now. And I did that for both the right and left side. These are both of the surgical guides. You can see it. And this is what they look like on the model. So I printed that maxilla as well, and you can see how easily they adapt straight out of the printer because of that path of draw hack that we did. These things seat right on they're completely definitive on their seating position. I know you could put in pins. That's totally up to you if you want to, but really I don't think they're necessary. A single finger just keeping this pressed in place is going to really allow you to make sure that that thing is fully seated, and you can visualize too that it's completely against bone everywhere. And so this is your guide, allows you to now make the osteotomies exactly where those need to go. Now the last thing is you do want to make some notes for yourself as far as where um, or I'm sorry, how much depth you've got to deal with. So let's go and look at these implants. And I'm going to look at it in the tangential view. Okay, so turn off all these other guides. And now just make yourself some notes as far as how deep can you drill safely. As I understand it, usually in the surgery, you just drill through until your finger, feeling through the skin, feels that drill vibrate through and perforate out the cortical plate. Here you can do it a little more precisely. Just grab your measuring tool, measure from the top of your drill tube to the apex of the implant. So here you see that I've got 49 millimeters of drilling depth. That would put me to right here. And I could also tell that if I go a little bit more, that I could drill to 53 millimeters before we're going to perforate through. And so that tells you your drilling depth. Now, some people like to design these such that you can just hub out your drill and know that you're at depth. That's purely a function of where you position this. Okay, so if I had a 55 millimeter drill, I could just scoot this up a couple millimeters and know that when I hub out this drill, that it would put the apex of the drill right here where it's about to perforate out the zygomatic process. That's really all that there is to these guides. They're very simple to do. Your biggest challenge in this is going to be to do a good segmentation and to really capture all of that thin sinus wall. Once you've got that, the rest of it is pretty straightforward. So I hope you found that useful.